Hello students, today we are going to study the next practical, that is practical number 9, to study the different flip-flops. Okay, in this practical we are going to study the different types of flip-flop. What is flip-flop exactly? So flip-flop is nothing but it is the counter and resistor. Okay, the building block of counter and resistor is the flip-flop circuit. Okay, so flip-flop circuit is what? It is the basic building block of your counter as well as resistors. Okay, so mostly you all can say that flip-flop is a bistable multi-vibrator. What is bistable multi-vibrator? Because it plays important roles in different types of your digital circuits such as your resistors, your counters and your memory circuit. So flip-flops are said as bistable multi-vibrator. Okay, because why they are said as bistable multi-vibrator? Because they play an important role in different types of digital circuits. Okay, so now flip-flop, it is mostly a sequential electronic circuit which consists of two stable states. Okay, there are two stable states for every flip-flop. There are different types of flip-flops which consist of two inputs and two outputs. The different types of flip-flop are RS flip-flop, D flip-flop and JK flip-flop. Okay, so there are different types of flip-flops. There are three different types of flip-flop. The first type of flip-flop is RS flip-flop. The second is the JK flip-flop and third is the D flip-flop. So there are the three different types of flip-flops. Now what is exact use of this flip-flop? So this mainly these flip-flops are used in the memory circuit. Okay, that whatever the circuits are designed, the memory is made up of flip-flop. This is the use of flip-flop. Now we will study in this practical the two flip-flop, that is RS flip-flop and JK flip-flop. Now what is RS flip-flop and JK flip-flop we will study. First of all we will study what is JK flip-flop. JK flip-flop is the flip-flop which plays a very important role in electronic counter circuit. Okay, mostly this JK flip-flop is used in the electronic circuit which uses the RS flip-flop. Okay, that is JK flip-flop. How it is prepared? It is prepared by using the RS flip-flop. So to build the JK flip-flop we use the RS flip-flop. Now in this we check the different types of conditions. Okay, here you all can see the diagram is shown over here, that which are the different types of how the JK flip-flop works. So this is about your JK flip-flop and this is the output of JK flip-flop. Here is nothing but this is shown as clock. Okay, that is the pulse you all are giving whether it is the clock pulse or which pulse, and this is the output. Here is the truth table of flip-flop. Now I will just explain you all from this condition of the truth table. You all can see this last condition 1 1. Okay, when this condition is there, that is when value of J is 1 and value of K is 1, then an important output is given and that important output is the togglance output. Okay, when this output is given, when the last condition is, that is J is equal to 1 and K is equal to 1, then the output is given as toggle output. Now what is toggle output? What is the meaning of toggle? Toggle means nothing but it is the change to opposite state. Okay, so it changes to its opposite state when you reach the condition J is equal to 1 and K is equal to 1. Okay, so in JK flip-flop there is a toggle state. Okay, now this toggle state is what? That it changes your output to the opposite state at every clock pulse. Okay, so at every clock pulse this output will change. Okay, that is in JK flip-flop there is a toggle state in which your output is changed to the opposite state at every clock pulse input. At every input of your clock pulse there will be a change in your output opposite to that state. Okay, then this is the truth table of JK flip-flop. So this is all about the JK flip-flop. The remaining conditions are when J is 1 and K is 0. So these are the different conditions which are given for the JK flip-flop. So this is all about the JK flip-flop. The next type of flip-flop is the RS flip-flop. This is the most common, or you all can say the most basic circuit which is used for designing or constructing the different types of flip-flops. So the other flip-flops are mostly constructed by using this basic circuit, that is RS flip-flop. In RS flip-flop, students, there are two inputs, that is one is S and other is R, and there are two output state, one is denoted by Q and other is denoted by Q bar. Okay, that is complement of Q. Now, what is Q stands for the normal output. Whatever is the general output, that is stored in a Q, whereas in the Q bar there will be the complementary output of the original one. So normal output is stored in the Q, whereas the complementary output is stored in the Q bar. Okay, here is the diagram of RS flip-flop which is created by using the NOR gate. So see here, the first input R and S. There are two inputs as I have said here, that is R is equal to R and S, and there are two output states, Q and Q bar. You all can see the one input of R and one input of S, they are connected together. Okay, the first input of R act as an output in second, and the second input of S is given as an output to R. So this is the connection of RS flip-flop using the NOR gate. In this, you all can see, student, there is the truth table of this. I will explain you all first. See the truth table, you all can see, when S is 0 and R is 0, then there will be NC. NC means there will be no change in your outputs. If S is 1 and R is 0, at that time your normal output will be 1 and your complementary output will be 0. When your S is 0 and R is 1, at that time your normal output will be 0 and your complementary output will be 1. And when both condition is 1, at that time you all will get a race condition. Now what is this race condition? That is, you will disable the state of your NOR gate. Okay, when you will disable it, then it will occur that there is a rest between both the NOR gates. In this situation, you cannot determine what will be the exact output. Okay, the output, it may be either set or reset. So we are not able to predict the proper output. In that case, we say that that state is the forbidden state or the rest condition. Okay, now I will explain you all the working of the RS flip-flop by using NOR gate. So see student, this is the diagram. I will show you all the working. In working, first case we will see that is the no change. Okay, that is when both input is 0. When S is 0 and R is 0, there will be no change in the state. Okay, then it will remain as it is, hence it is called as no condition state or NC state. Okay, now second input is when S is 1 and R is 0. So when your S is 1 and R is 0, it means your lower OR gate is disabled. Okay, your lower OR gate is disabled, which will produce output 0. Okay, so your output will be 0 for this, whereas it will produce to your upper NOR gate as 1. So that output will be 1. Understood? That is when S is 0. Sorry, when S is 1 and R is 0. So when S is 1, Q is 1 and Q bar is 0. Understood? That is lower input to your upper NOR gate will become 0 as, see, first input is R. What is the value of R is 0 and value of S is 1. Okay, R is 0, S is 1. So what will happen? Your lower NOR gate will be disabled. That is, value will be 0. So 0 and R is also 0. 0, 0 will produce 1. Okay, 0, 0, if we have 0, 0 as an input in NOR gate, the output of that is 1. So your Q will be 1, and if both is 1, then output is 0. So here will be 0. So this is the second condition in which we have checked for output when input S is 1 and R is 0. Okay, so this condition is called as the set condition, and in this condition, your circuit will be latched. Okay, so this is the set condition. Now next condition is of opposite, that is 0 and 1. In this, what will happen, your upper gate, NOR gate will be disabled, so Q will be 0 and your lower will be set, and so your Q bar will be 1. And last condition I have just explained you on that, when both input is 1, then in that case, according to this, we will disable the NOR gate. Both the NOR gates will be disabled. Hence, we will not be able to predict the proper input, whether it is set or reset. So in that case, we will say when we are not able to predict whether it is set or reset, then that unpredictable state is called as the rest condition or the forbidden state. So this is about the RS flip-flop. In this way, in the 9th practical, you all have to write about what is the flip-flop, definition of flip-flop, uses of flip-flop and JK flip-flop, then diagram of JK flip-flop, what is RS flip-flop, and diagram of RS flip-flop with truth table. Okay, so this is your next practical, that is practical number 9. Now the last practical, that is practical number 10 of CS2, is to study the 4-bit binary counter. In this, you all will study about the 4-bit binary counter operation. Okay, in practical we are not writing much theory, so I have just taken the important points. In the theory lecture we will cover the remaining points. Okay, now in this we are going to study the 4-bit binary counter. Now first of all, students, what is counter? Counter is an electronic, you all can say electronic digital counter is nothing but it is a flip-flop circuit which is capable, or which has the capacity to count the number of blocks, pulse, number of clock pulse which is applied to it. Okay, so it produces you all the binary output in the particular sequence. Okay, so in counter, what happens, the flip-flop circuit is capable of counting the number of clock pulse which is applied to y'all. So it will produce you a output, that output will be in sequence. So in this, you all can count the total number of states which is produced by the counter, and that total number of states will be denoted by M, and that M is called as modulus of counter. Okay, so again this, if you want to calculate the modulus, you can use the formula as mod of counter is equal to 2 raised to n. Okay, now for example, we will take the example of 4-bit binary counter. Now student, 4-bit binary counter is one of the application of flip-flop. As I have said that flip-flop circuit is capable of counting the number of clock pulse which is applied to it. Okay, so in this, flip-flop is one of the application of 4-bit counter. Now in this counter circuit, what happens, it counts the number of pulse which is given as an input to your circuit. In 4-bit binary counter, you all can count the input pulse in the form of 4-bit number. In 4-bit binary, what you all can do, you all can count whatever the input pulse you all are giving in the form of 4-bit binary number. That is, this type of counter is used to design the least number. That is, the possible combinations will be from 0000 to 1111. So there are different possible combinations which are used in this 4-bit binary counter, which gives an input pulse in the form of 4-bit number. That numbers can be from 0000 to maximum 1111. That is, in this circuit there are different 16 states, so the modulus of counter is 16. So hence 4-bit binary counter, which consists of 16 different outputs, then it is called as mod 16 counter. So why 4-bit binary counter is called as mod 16 counters? Because it consists of 16 different states. So here is the diagram of 4-bit asynchronous counter. Okay, now in this, what is there, you all can see in this diagram, it consists of 4 JK flip-flop. There are 4 JK flip-flop named as A, B, C, D. Okay, A, B, C, D. These are the 4 JK flip-flop. They are connected in toggle condition. Toggle condition, it means when J is equal to 1 and K is equal to 1. We have seen in that previous practical that when the in JK flip flop toggle condition occur when the value of J is high and value of K is high. In that time the input will be the square wave and that is the clock to the flip flop. So input will be the square wave which will be given and the remaining all the flip flops will be connected to the negative edge. Okay, hence it will change its states. Hence each flip flop will change their states at negative edge of the clock and corresponding to that the output will be given as Q0, Q1, Q2 and Q3. Okay, so this output, how the output is generated, that we all will see in the timing diagram. So this timing diagram is there in which you all can see how the flip-flop is cascaded. Here I have given the information, all the information that square wave is generated. See, this is the square wave when the toggle condition is occurring. So these are the different types of output and that is written over here. In the timing diagram, see this is the, here below is the timing diagram. In this you all have to assume that your input is clear 0 0 0. Okay, your basically input is 0, all your inputs are cleared to 0 0 0. Okay, here I have given the working, you all can read it later. Now I will explain you all, just see here. As the clock 1 arrives, the clock terminal of the flip-flop A, it goes to the output high. See here, it goes to the output high and high you all can say or 1 and at the negative edge of the first clock pulse. When at the negative edge of the first clock pulse. And hence your output Q0 is there, that will go from 0 to 1. Okay, so your output Q0 that will go from 0 to 1 and which is the positive end. So here 1 is called as the positive end. After that what will happen, the transitions of the clock will go to next flip-flop and when it will reach to the next flip-flop, the previous one will remain in the same state. Thus other flip-flop, that is B, C, D, will show you the output 0 0 0 and output of the counter will be 1. Okay, that is Q3 will be 0, Q2 will be 0, Q1 will be 0 and Q0 will be 1. Understood? So how will be your output? 0 0 0 1. As it is towards the positive end, your output will be 0 0 0 1. Understood? Then when the next clock pulse will go, then the negative end of the second clock pulse, that is of the flip-flop A, will change its states from 1 to 0. So it will change their state from 1 to 0 and again the same process will continue. Okay, then in this way this is the working, or you all can say this is the timing diagram of counter. That is 4-bit binary counter. In 4-bit binary counter, students, keep in mind that why it is called as 4-bit binary counter. You all have understood that what it uses. It uses different 4 types of JK flip-flop. 4 flip-flops are used and all the 4 JK flip-flops are kept at the condition, toggle condition. What is toggle condition? That is J is equal to 1 and K is equal to 1. That condition they have kept and they have connected it to each other by using they are connected to each other by using the toggle state. That is J and K is kept to high and then whatever the input is given, that input is given as a square wave. Then what is the output generated? That is generated at Q0, Q1, Q2, Q3. Okay, this will give you the binary output. Okay, so when you will have the input, it will be for A, then it will go to from the flip-flop B to flip-flop D. There will be nothing changed, but your previous flip-flop, that is C, will have some change and the output Q1 will be displayed on that. That we will see in the theory lecture in detail. You have to remember that JK flip-flop are used and the input is given as a square wave to your binary counter, and in this you will count the make the additions, and JK is in the toggle state, or you all can say what is toggle state, that is JK is set to high and output is Q0, Q1, Q2, Q3. Okay, thank you.